Okay, friends, I'm super excited knowing that we want to do something very, very, very awesome. Now, if you've read the post I made like early this morning, talking about a project which we did at about the early hours of this year, I think about January, there about. So we did a book summary apps. So it was a gig which we did a book summary app, and we used. In fact, the method we used in designing that app was really crazy. Thinking about it today, yes, that now. I mean, there are ways that we would have done that very effectively and reduce time and so on and so forth. So that was what really inspired me to do this teaching today. So put your seatbelt on because today we're going to dive deep into NLP. And what I want to do today is it's a part of NLP anyway. So we'll be looking into that, and it's called summarization, NLP summarization. And it's really an interesting subject because what it does, it help you classify a full book and summarize it into something of choice. So if you look at the diagram which we have on screen now, so this is just a display. I did a Google search to get this, so you can see that this is a document, a pile of documents, and it can be summarized. Rather than having one human to summarize it, or rather than having humans to summarize it, you can have your system do that. Just write some lines of code and you would have it do that. And it's simple, it's super cool because this text summarization can be looked at from three perspectives. So we can have the based on output. So we're doing the summary based on output type, and we can look at input type. But the one that really the one I love most is this based on purpose. So what's the purpose of the text? So the computer look at it, weigh the text, weigh everything, then comes out with the best projection. And often the time the best projection is it's always cool. So let me not bore you with some, there's a pack of theory attached to this thing, and it's really super because the very and this is a flow diagram of how it goes. So okay, this if you want to look at it from a conceptual standpoint, then you'd love to read details about this and see what Google team are doing about how to enhance the NLP algorithm. So this is how this is more or less like your flow diagram. So the start, you load up your document, you pre-process the document, which involve cleaning, stemming, and the rest. Then you do your frequency flow validation and the rest, then calculate and come up with the summary and the rest. So it's really an awesome process, and we're going to follow this diagram to do everything here in order for us to get the work done. So enough of me giving you boring lecture of how to do this. So let's just dive quickly into it and see how we can get this thing done. Okay, so for those of you that coding with Anaconda, you can just come launch your Anaconda from there. However, Anaconda takes your RAM a lot. So something I would advise you to do is just to come to your window, locate your Anaconda folder. So this is my Anaconda folder. Then go to your Anaconda prompt. So this is my Anaconda prompt. So load it, and we'll be using Jupyter Notebook. Trust me, you can use any other IDE, but somehow I just love using Jupyter Notebook. So it's light, and it would get it up and running. So it loads up my default browser. My default browser is Chrome, and here is it. So let me start up a new work project. So I'm using Python 3 and I'm starting it up now. So let's get fire down. Okay, I think the very first thing we need to do, because if you look at this diagram which we had here, is to load in our text. So what text do we want to summarize? So I'm just thinking, okay, so let's do a simple Google search. So let me just come here and put in text summarization. Okay, good. So let's do, and let me go to, I think I would prefer to use Wikipedia. Wikipedia has a lot of resources there, so let me just click on Wikipedia. Okay, so you can do this and read more about this text summarization, automatic summarization, read more about it and the rest. So let's say you have an article, maybe a project in school, or you're filling an application form or something, and they asked you to summarize. I mean, this is a trick which you can do, but let me not go there. So you want to summarize a book or a document, so I'll just copy file from here so that I would use it. So let me just copy a bunch of files. So I want to make it like huge, so let me just copy almost everything from here. I think this is okay, or rather, I think what's stopping me, let me copy more. Okay, so I just copied the whole of the document found in this page. So let me come back to my Anaconda, and I would say text is equals to, so I need to create a string of that, come here and paste it. Wow, this is our text. Okay, so let's run this cell. So I've run that cell. Let's check our text. So if I run this, so this is our text. So this is super cool. So this is the whole of the document which we copied from Anaconda. You can see them here. This is really huge. Of course, I can't give my boss to read all of this. I need to summarize it. I mean, that's the purpose of what we're doing now. So let's get our hands dirty to this. Okay, so the first thing I'm going to do, should I make this a markdown? Let me make this a markdown cell. So I would of course, the first thing I would want to do is to import in my libraries. So let me bring in the libraries which I'll be using. So the very first library which I'll be using is of course, let me just load them. I love having all my libraries ready. I don't know if I would use any, but should in case I will, I mean, what's stopping me? So this should be np. So let me follow the standard. Import pandas as pd. Okay, so the next thing I would import is let me import regular expression, and let me import time. I might not use all of these, but I love having them available. Oops, I almost forgot. So let me import math matplots lib.pyplot as plt, and let me import Seaborn. So I just love having all of these in as SNN. I just love having them in, so should in case I would use it, so I would use it. Okay, so few library which I would want you to do, you might not have, if you're using Anaconda, you're likely not to have space C. So what I would advise is for you to download it, and for you to download it, just use the pimp command. So you say pimp install. So you just do your pimp installed. I've already installed it, so you would need it. And the other thing which you would need again is to say okay, you can check a Spacey website to see other things which you would need. I think you would need to download their package as well. Don't go for the large, their web core. Don't go for the large, just go for the small. I think the small would do. You don't have to, well, if you have data and you have space on your system, I would advise you that you download that. But if you don't, please don't do that, you understand? So that's cool. So the next thing I want to do now is for me to import Spaces. Since I've downloaded it, so I have to use it, so I'm importing it. Okay, now that I've imported Spacey, what I would want to do again now is to import in, I think I should do this. So I would say from spacey dot okay, so okay, dot lang. So what language are we using? Of course I'm using English. And something I can do now is for me to come put up my stopwatch. So what I did was to press my tab so as to bring up those bring up the IntelliSense in order for me to know what I want to use, because sometimes this thing gets weird. Okay, so I would import in the stop words. Okay, so the next thing I'll do is to say from from string import punctuation. Okay, now that I've gotten all of these, so I think this is cool. So remember what we showed here. The first thing to do is to do our data processing. So we have to clean the data and the rest. So what I would want to do to avoid any form of error is to convert these cases. Like for example, you can see this row, it's all in uppercase, and you can see this note is in uppercase. So let me just copy this and put it here. Now anytime, to the human eye, if we see notes and we see this, we see both of these as the same thing, no different. A note is a note, you understand? That's how we see it. But the computer doesn't see it like that. The computer sees this, the computer thinks this is different from this, and because of that it might give us some loads of error. So to correct that, we need to write a code that would help the computer understand that everything on uppercase should be converted to lowercase, so that the computer sees it as one entity. So how are we going to do that? It's very simple. So let me just say x is equals to let me say the note which we just copied. Oops, sorry about this. Which is equals to the note which we just copied. Of course I have to make this a string. Okay, so that's cool. So now I can say x is equals to, let me say, x dot lower. So what this does is to convert all the uppercase here into a lowercase. So if I run this, you'd see that our note now is all in lowercase. So if we have note upper or lower, you understand, it converts it all into one text file. So let's move on. Now that this is clear, so let's apply this same thing to this our text here. So I'll come here and say text is equals to text dot lower. Cool. Oops. Okay, dot. Okay, so now if I check on my text, you can see we have everything has been changed. You can't find any capitalization here, so that is what we want to achieve. So this is pretty cool. Okay, so now let's check on something. So remember that we imported stop words. Okay, good. So you might ask yourself, what are stop words? So let me just scroll up. Let me scroll up. Okay, where did we get that in? Okay, this is it. So we brought in stop word. So let me copy that. So what are stop word? So let me say stop is equals to that, and let me print out that stop word. So what I just did, okay, so now we can see this stop word. Now these things are words, but they don't add meaning to your words according to the computer. It's not like it does not. Of course we know what above means, we know what after means. So if we don't have after to your word, we might not have the right meaning, you understand? But to the computer, all of these does not have weights in defining the meaning of a word. So they are called stop words. So what we need to do is to remove them from here, from these words here. And what that does, it helps to reduce the size of our words, so that by the time we feed it into our neutron or our neural pathway, we won't have so much an heavy file. You get that? So that's the key reason why we need to remove this. Okay, so what I would want to do first of all is to copy this and come paste it here. Now if you'd observe, this thing is not in list, so what we want to do now is to put it into a list. So I'll just cut that out and type list, paste it there, and if I come here and do my stop, you can see that now it's now in a list, Python list. So that is good. So remember that we imported another thing, which is punctuation. So what are punctuations? So if I run this, you would see these punctuations. So these things we need to remove it again, because when we're doing vectorization or tokenization, it shouldn't be counting these as part of the word. We just need the word, we don't need all of these things. Is that okay? So to do that, we are just going to bring them out. But then if you look at this stuff, I can see one weird stuff here, which is this here. We don't need this as well. So we need to add it into our punctuation, because if you look here, you can't find that into our punctuation. So let's do that. So I'll say punctuation is equals to punctuation plus, so I'm concatenating that into this. Okay, so that's good. So if I call on my punctuation, you can see that this stuff has been added into it. Okay, good. So now that we've done this, we've actually prepared our data for cleaning, processing, and the rest. So now I would say let me do NMP. You can name this anything, it's self-defined. The reason why I'm using NLP is because this is what Spacey used from in their website to define this, and somehow I'm just clue to it. Is that okay? So it's your choice. You can use anything which you'd want to use. Okay, so I'll say Spacey .load. Now remember that I said you should download a file, so you really need to download this file as well. So it's actually underscore core underscore web underscore sm. Now you should download this file from Spacey website. You understand? You should do that. So if I load this, it loads my NMP to be that. So right about now we need to redefine this our text here, because we're preparing it for tokenization and the rest, so we need to define it by that. So we're going to sample this text into these files which we've downloaded. So to do that, I would say sometimes naming these variables are somehow, so I'll just say document. So this is our document, and I'm naming it document because we named this document. So we're saying load text document, that's why I'm naming it document. So I'll say document is equals to NLP. So we're taking from here, you understand, and what are we going to put inside this bracket? We're going to put this text. Good. So that's what we're going to do. So now I would say text. So if I load that, we've loaded our we've sampled our text document into this core. So now let's load our document and see what that looks like. Now you can see what it looks like. So it's not different from what we originally have, but it's well processed and a little bit cleaner now. So right about now we're going to do something super cool. So now we need to prepare a dictionary, because what we want to do is we want to bring out the word frequency. So we want to check out how many times the there appears in this whole sentence. How many times does a recommendation appear in this sentence? So with that, now we can do some magic with it. So let's see how that can be achieved. So I would say let me give it word frequency. Yeah, so let's just use, so I'll just say word freq is equals to an empty dictionary, because we'll be bringing those words and we'll put them inside this dictionary. That's cool. So now I would say for words, or for word rather, in where? For words in this document. Please, I would need you to pay good attention, because this is the point where you can easily get confused and lost. So we'd say for words in this document, right? So remember the for loop. So what the for loop is doing is to iterate through every word inside this document, and that's what we want. Now remember, we want to fill in this point here, so we'll be checking out for word that exists and word that does not exist. You understand? So those are what we'll be looking out for. So I would say for word in text, sorry. So I would say if word in text is not in, if word in text is not in the first one, which we need to do, of course, it's to say our stop. So let me work with the stop. So with the stop, so okay, that's good. So I would now do another. I would say if word dot text not in punctuation, yeah, so punctuation, so we'll do that, punctuation. Now note something, because we've already done converted it to lower, there's no point converting it yet to lower again. So it's your choice, you can keep on adding this conversion to lower, but upon looking these, our conversion up there worked, so there's no point adding this anymore. So I'm taking that off away. So now that we've done this, so we've taken that off. So another thing we would now do is to say if word dot text, okay, not in, now we're using this our word frequency, so that means it's seeing the word for the first time. You understand that? So that's what we're doing there. So we'd say dot keys, so that it counts or record that key. So now I would now come here, copy these. I'm trying to be fast with this. So, and I would say word dot text would be equals to 1. So if it sees this for the first time, it's equating it to 1. But then if it sees it again, so what I'll just do is to copy the whole of this, Ctrl C, Ctrl V. Else, if this is not the first time it's seen it, let it be +1. You get that? So it adds an increment of 1 to it. So let me run this cell. So that's good. So now let's check the word frequency and see what it looks like now. Wow, can you see this? Can you see this? So what we've successfully done with this simple line of code is to count each data or each word, how many times they appeared here. So from what I can see here, we can see summarization 60. Whoa, that's cool. And if we look down, we can see summary appears 27 times. If we look more, you can see how many times some words appear. Like I would usually advise, don't pick the highest word by looking at it like this, because trust me, you might not know. So how are we then going to check out for the maximum words that appeared here? So of course we can use a function, and that function, so let me just call this, let me say max frequency. Okay, so we can use that to check it for. So and I'll say max, and I'll come put in these words here and say dot values. So what this does is to check, iterate through here to check for the max word. And if I run this cell, and I think I should just do this in the same cell here. So if we run it, 60 is the most frequent word that was used, which is these. Wow, that is cool. Okay, now it's getting more and more interesting, even though it's very simple, but it's getting more and more interesting. So what would want to do now, is to create a factorization of these. More like, want to divide the highest words, the highest frequency of word by every number here. So that would, because what we're checking out for is actually a probability. So probability of words, how they appear, so it helps the system to understand the strength of those words in the sentence. You understand that? So that's what we want to do. And of course, you know that probability is between 0 to 1. So by dividing it by 60, dividing everything here by 60, would use it to get the strength of that word. So what I'll do now is to say for, let me use word since we're using word. So we'll say for word in in this frequency word dot key, because we're iterating into it. We're iterating into it. So I'll copy that frequency word, open my square bracket, and put my word. So this would now be equals to let me just copy this, Ctrl C, Ctrl V, divided by what's the maximum frequency, which is 60. So rather than add coding it, so we could just put that in. So now if we check for our frequency word, let me just take this out, and if we check for this, we'd now see that our summarization is now 1.0 and others is divided by 60, so we'll be seeing a fraction of numbers. Okay, so this is beautiful. This is really, really beautiful. Now this whole thing which we've done for the word, we're going to repeat that process. We're going to repeat it for the sentence. Wow. Yeah, we're going to repeat it for the sentence. So now let's do that now for the sentence. So I'll come down here and I'll say let me say sentence, and I'm thinking what I should name it as. So let's just call it sentence, let's say sentence tokens. Yeah, let's say sentence tokens. Now I'm going to do some for operation here. So I'll say token, okay, for token in words. Now we're going to, now when we say token in what, now that should be, remember these are documents, so this is where we want to pick the sentence from. So I'm copying this document, come down here in document dot, because we're not picking everything, we just need the sentence. So we'll just say sent, sorry about that, so we'll just say sent. So once we do this, and let's print out that so that we can see what that means. So if we load it up, you can see now that we've gotten each sentence from the statement. Now note how in normal sense, if you want to identify the sentence in a word, it's every sentence ends with a full stop, right? Yeah, so that's what we're doing here. So if you check out this, rather let me just come down here and load up our document, so let's make that comparison. Now you would see that the first says there are both the two type of extraction summarization tags depending on what the summarization program focuses on. So you can see a full stop here, and you can see this whole thing, the same thing with what we have here, the same thing with what we have here. That's what we can see here. So it ends with a full stop, then you see a comma, then it goes to the second sentence, end with a full stop, and you can see a comma, then goes to the next. So the same thing we can do here. So if I trace this guy to where we have our full stop, you can see that full stop. So what this has done, it has broken the sentences, just like we did earlier on breaking the words them. So it breaks it in sentence. So what we're going to do now is something very interesting. We're going to do a for operation so as to get the sentence frequency as well. So let me use the right word. So let's just do sentence frequency, and of course we're creating a dictionary for that again. So now we have this. Now follow me closely. So what I'll do now is to say we'll say for I'm thinking, so let's just use sent. So for sent, and it could be anything, you understand? You can say for sentence, I think I should just use for sentence. Okay, so for sentence in In where? Think, where should it be? In this our token. So because this is the sentence, this is a sentence, so we want to iterate this sentence. Okay, so I'm copying that, come down here. So for sentence in that, then come down. Then now we'll now say for word. Now what we want to do now is to iterate each word in this sentence, because now we've gotten each sentence. So it's to now say for word in sentence. Yeah, so sentence, which is this guy, that guy. Okay, so that's beautiful. Now we've gotten those two. So now we can now do something tricky. So I can now say if I think we should go with word first. So I could say if word dot text. Remember that you can still convert it, because should in case there's a capital letter here, you can still convert it, but I'm very positive that there's no more capital letter, so there's no point we doing that conversion. So for if text in, now we're going to use our word frequency. Remember our word frequency? Yeah, that's what we're going to use. So I'll just say word frequency dot, we have to use our keys. Okay, we really need to use our keys. Okay, now that we've gotten this, now we'll repeat almost what we did here, but this time around we'll be walking through it with the sentence. So I would say for sentence, yeah, for sentence, then let not necessary, but I think you can if you want to, but then it's not necessary at all. So not in, now note the difference here, not in this our word frequency. Good. Remember dot keys again, because we want it to iterate in that count. So what I would now do is to say that word frequency. Okay, now sentence, because we're iterating through here, would be equals to this our frequency, this our word frequency, then word dot text. Note that. So now let me copy this, because what it's doing is to check if this already exists in this iteratable. If it's not, let it repeat the process, but this time around increase the count, so that if this word does not exist in this our sentence frequency, let it increase the count. Okay, so that's beautiful. So let's run this. Okay, that's good. So if I call that now, let's see what we're, whoa, this is super cool. This is really cool. Now if you look at this, remember what we had with our words here. So checking each word and checking out the frequency of the word inside that sentence. So that is what we've done here now, but this time around we did it for sentence. Okay, and now we can see the frequency of this word, how weighty this sentence is in this expression or in this sentence. So that's beautiful. Now the computer can start thinking to know what word is important, or rather what sentence are important. So it looks at this is rating 3.5, this is okay, and it makes that comparison. So if you look down, remember what we did for marks, you can still do that to check out which is the maximum sentence, but let's not do that. So let's go straight up to what we want to do. Now that we've achieved this, what we need to do now is to compare this with our length now. So I can now say length max. So let me just use that, length max is equals to, so let me do int, and I'll use my length function and call this my frequency. Yeah, good. So let's do that and see what we would get. And let me call this and put it here and call it down. So wow, you can see the number of words which we have here, number of sentences which we have here. So this is really much. Okay, but then that's cool. Now the next thing we want to do now is for us to use this function here. Okay, so we've not called that function, so now let's call that function. So I would say from help q import n largest. Good. So let me just copy this. That's a package that comes automatically with Python, so you don't have to bother yourself about that. So let me just say summary, because of course we have to summarize that. So I'll do this. So summary will be equals to that our end package, and let's look at the documentation of that. So we'll see that it will take n variable, then it will take an iteratable, and of course it will take our key. So what is this our n? Now the n is referring to the number of sentences which we have in our expression, and that number is this, right? Then our iteratable, where are we getting our iteratable from? This is where we're getting our iteratable from, definitely. And of course we need to set our key. So now let's do that. So I'll just come here, copy that my max, and put it there, so that becomes my n. Come here, copy this value, and this is our iteratable. And of course I have to state the key, and the key would be iteratable dot get. Yeah. Okay, so let me run and see. Okay, beautiful. You can check out the summary now. You can check out the summary. So this would be what the summary would be like. So now the computer is summarizing by itself, but then this summary is crazily too much. So what if, because definitely my boss cannot read, so not like my boss cannot read, but he doesn't have this time. So what I want to do is to make it even much more smaller. So I want to make it even much more smaller. So what I would do is to take this value here, this value which we have here, multiply it by a fraction. So let's say I need a 30% of this value. So I'll just say times 0.3 or 0.3. Yeah. So if I do that, of course, you know, this value would change. So this is 69. So 69 is the 30% of this value. And if I run this cell again, this value would change. And if I come run this my summary again, you can see that this value has changed. Okay. So what I'll do now is to say, okay. So still on this. Okay. So still on this. So now we've gotten that, but what I want to do now is to copy this cell, put it here, and copy this cell, come down and put the cell there. Okay, and I think that's cool. Okay, so let me just copy this cell and put this down here. So I need this thing to be smaller, so what I'll do is to multiply it by, let's say, 0.5. so I just need 5% of whatever this text is, and run this cell. So if I run this cell, you can see what 5% is. Now I might be feeling like this 5% is even too big, too much. So let me even reduce it some more. So let me just take it to, like, let's say 3%. So we just need 3% of the word, so summarize it to 3%. So wow, this is what the summary of 3% is. Now let's look at this. What's actually happening here? Remember this thing we did here. So what it's doing, it will pick up it will sort it into the most highest value. Do you understand? So the most highest value. For example, I'm looking at my time. I'm really struggling with my time. Okay, good. So let me come here and let me add more. So let's see what's actually happening here, or rather, okay, let's just move on. So now that we've gotten this is super cool, but then if you look at it, it's not properly arranged. Okay, so this is what we're going to do. So let me just say final would be equals to, I need to iterate it so as to get it well arranged to an extent. So I would say word.text, and I'll now say for word, okay, for word in this summary. You can see how simple this thing is. Very, very simple. So I run that cell, so we've gotten that. So now if I run my final, you won't see much of a difference, but you can see that it has closed up itself. But then I don't like this comma which I'm seeing here. It does not make sense in any way at all. It doesn't make sense. So now let's take it out. So what I would now do is to name this to be my final model. So this would now be my final model, where I can now say, okay, what do I want to do? I want to join that cell. So I'll just use my normal list method. Then that should be final. So if I run that and I call my final model, and voila, this is it. Isn't this beautiful? Isn't it amazing? So in just few lines of code we've summarized. Now I'm seeing this and I don't like that. Can you see that? So what's actually happening, because we've done joining, so what this thing is saying is it's breaking to a new line. That's what it's doing. So we can remove it. So what it will do is to call, let me just say that is equals to, I would say, replace. And what are we replacing? We want to replace this \n with what? Of course, nothing. Don't want to replace it with anything, but I think I should just use a space. So let's call our final model, and voila. So we've gotten that. And is there any? I think this space now is too much, right? Oh, I think it's okay. It's okay. Yeah, that's okay. Okay, so this is beautiful. So what you've successfully done, if you're following me, is that you've taken these whole words, and compress it into something like this. And isn't that amazing? Into this. And trust me, you can beautify this some more. You can create a class where you just or use it to create a software where you just put the word and it brings out an output, and the output will be the summarized word. So depending on the percentage of word which you want to get, you can always get it out. That is how you can do text summarization. Very, very simple. When I say simple, I mean very, very simple. That's where we'll call today. So see you in subsequent training. Thank you.